Hey guys, welcome back. Okay, so in this episode, we're going to have to revisit the add new pool and aligned malloc routines a little bit because I made a bit of a logic error in the last episode. I don't know if any of you noticed it. You may have, you may not have. So what we did isn't going to work. Now that's not to say that the last episode was a total waste. It was not. Actually, what we're going to do to fix it actually relies a lot on the information that we did in the last episode. So the last episode is not a complete waste or anything like that. But we have to fix something. Now, hopefully this is the last time we have to do this. None of this has been tested. We haven't really been able to run this yet. So, there is this possibility that what we're doing may not work. There may be a bug in it somewhere, but, that's going to happen from time to time. We're going to have to go back and look at stuff that we've already done and maybe fix it now and again. So, don't let it stress you out. I try not to let it stress me out too much. So let's take a look. So I drew this really nice template that we're going to use. Kind of a crude drawing, but, better than my normal squiggly lines when I'm doing this. First of all, let's take a look at what we did and explain why it's not going to work. So let me pull just a second here. Okay, so let's take a look at the Memory Manager class, the CPP file. And let's take a look at what we did, and I'll explain why this isn't going to work. So we collected basically two different addresses: the original address, the original memory address, and the aligned address. Okay. So I guess the best way to explain this is, let's go back here. Let me create a new layer here so that we can draw all over it. That's fine. So I'll just do this with a mouse. I think I can do this with a mouse. I don't need the drawing pad. That's fine. Except I do want to write. Maybe I do need the drawing pad. Okay, so you will remember that we originally wanted to malloc this much, so all this stuff in here, kind of all this through here, all this memory. We wanted to malloc all this stuff. Now let's say this is byte 0. And we wanted to allocate, say, 500 bytes or something. So this is going to be byte 499. And what we did was we had the certain alignment requirement. So we split this into some amount of stuff, and these are going to be the aligned bytes, or the alignment bytes. This is not easy to do, this writing with this thing, because of course I can't see it on my pad. So pretend that says alignment bytes. So somewhere in here we decided there's going to be an alignment, and say it's here, right? Say this is the byte that aligns. So this is our aligned memory. Okay. Oops. So this is where we would actually start writing, and we would go this way. So basically, even though we asked for 499, we got a few extra. Okay. Then what we did is we had this extra space back over here where we wanted to keep this pointer right here. This is going to be the original. And you remember we needed to save this. So how do I put this? So we could have put it here, right? This is what we set this up for. And we may end up doing, if alignment bytes happens to be aligned right at the front, we need enough space to put it in. But once we found this aligned spot, then we took that pointer and because we know, let me erase this out, we know that once we found this aligned position, we no longer needed any of these bytes. So we took this original pointer and we put it here. And that's a pointer, right? It's a pointer to this thing. And so we kept that there. This is all garbage bytes. We don't need any of this stuff, right? This is just the extra that we no longer need. And then we kept that original pointer, and then this is our memory. So that's what we did. Well, let's see if I can grab. Take a look. Sorry, that's not it. So that's basically what all this is. Well, then we went up here, and what we did is to the add new pool is we used this new block to do a new with a placement new. And what we said was, and we placed it at the pool pointer, which is the aligned memory, right? We grabbed it from here, which is the aligned malloc. Aligned malloc returns the aligned pointer. So we did a placement new of this class. So when you do a placement new, all it does is it sticks. Whoops, I got the pen turned around. It sticks it right here on top of aligned. This is our memory pool class, right? So what's the problem with that? Well, that's got a couple of problems. It's not going to work, right? This whole system would work if we were just mallocing this area and then just using it as a malloced area, but we stuck a class on top of it. Now, for one thing, the memory pool class itself is going to take up some space. So let's take a quick look back at the code again. So the memory pool class, I think right now, doesn't have anything in it. But let's see if I can move this real fast. Let's throw a couple things in there that I know I'm going to need eventually. First, hang on a second. Yeah, let's do private. And we will do okay, let's do it this way. Aligned memory pointer and a void star original. Okay, what is going on? Why is that doing that? Okay, and I'm actually, well, I'll do that later. So there's a couple of void stars in here. So the class itself is now going to start here, right? And it needs space for those pointers, right? So it's going to put pointers here, and it's going to put pointer here, those two pointers that I just put in, right? And the size of those pointers is going to vary. It's either going to be 8 bytes or 16 bytes, depending upon if you're at a 32 or 64-bit operating system. Look what's happened. We've got a pointer sitting right here. What's going to happen if I write to that pointer? It's going to overwrite this, right? So, and the thing of it is, right, is as I put more stuff in here, like if I could put a character, I'm just going to call this misaligned. You'll see why later. The more stuff I put in, the more it's going to bleed into. So now we've got a character byte right here. It's going to bleed into our memory, and so, and every time I write to this, it's going to overwrite all that stuff, right? If I try to write into that dynamic memory, so that's not going to work. What we did there, okay. So how do we fix that? Well, what we want to do is very similar to what we did before. And I'm going to grab a new layer again, and then let's turn off this one. So, because we're now going into a class, and I'm going to keep the original memory pointer as part of that class instead of keeping it as a malloc, we actually don't really need to, let's see, where am I trying to go here? Why do we have memory blocks up? Let's get rid of those. I don't need those. We're the global manager at this point. Okay, so let me take a look here. We no longer need to keep this void star inside that malloc memory, actually. Right, but what we do need to do, instead of keeping that void star, what I'm going to do is add in size of memory pool class. Okay. I now no longer need this. Well, let's see. I'll keep that for right now. Yeah. What I'm going to do is, instead of trying to dump this in, I'm going to actually return it as a parameter. So let's do void star original, and then we can dump this out. And in the memory manager class, right down here, void original. Okay, so that we no longer need to keep this. This is no longer necessary. Okay, let's talk about this line for a minute. So let's go back to Photoshop. All right, here's the thing, guys. There's a few things we want to keep when we do this. Now, just like before, let's see, where's my, there it is. Just like before, we need to keep this address. This is so we can free it later. We're going to keep let's see, how do I want to do this? We're going to keep an address over here. So this is the original. We're going to keep this address, which is the aligned. This is aligned to our class. Also, we're going to keep a third one now, and this may be out here. It's going to be somewhere between aligned and the first byte of our memory, and this is going to be our, what are we going to call this? This is going to be our aligned pool. Now you might ask yourself, well, what's the difference between aligned and aligned pool? Let me see if I can aligned class instance. All right. So no matter how big the class is, it's going to take up this much space. Okay, right up to the edge of this one. And it's got to be aligned. The class itself has to be aligned. And what goes in here are the variables that are part of that class, right? Which I've currently got 3. I've got a void star, or two void stars, and a character. Okay, and that's what's going to fit into it. But no matter how big this is, we want that to work. So we're going to generalize it. So you can see we're keeping 3 different things now. And we're going to keep them, instead of keeping them as pointers inside of here, inside of the actual malloc memory, we're going to keep them in the class itself. So they will live in here, but they'll be part of this whole thing, right? And we don't have to manually place them in there. The class will do that for us. So they'll live in here. Okay. So how do we align this pool and align the class? Well, actually, we have all the tools we need to do that already. So let's take a look. So what we want here is, what we've done is we've started here, right, at this byte. We did that fancy math to get back to here. Now we want to do some fancy math to get back to here. And actually that fancy math is not so fancy. It's pretty simple, actually. So let me drop back into, I keep losing my spot. So what I'm going to say here is aligned is going to be equal to all this stuff that we already have. That gets us this one right here. And I'm going to actually subtract off right here minus size of memory pool class. Okay. And I'm missing a delimiter. So what aligned is actually returning at this point from the aligned malloc is this address right here. That's what we're getting back from aligned malloc. This address right there. And remember, we set up room for it up here because we told it to add in the size of the memory pool class itself. So we've got room for that. So we're good there. Okay. So we just got to keep in mind that what we're getting back here is from the memory match class is the address of the class itself. Okay. And also we're getting back the original malloc memory location. Okay. Okay. So that's what we need from that. All right, let's take a quick look at add new pool again. So, let me look at this for a second. I keep putting in the word block, and I don't want the word block. I want pool. So let's change that. Pool size is what I want. Let's see, I used new block. Let's not use new block. See, the reason I want to stay away from block is block means something different, and I keep here, give me that. I keep mixing them up, and it can be confusing. I don't want this to get confusing. So, okay. So remember, actually, okay. Let's change this to aligned pool pointer. There we go. Now we need to put in here the reference to the original pool pointer. That's going to be the address we need to keep for freeing purposes. There you go. And then also we need the third one, which I'm going to call star the aligned memory pointer. So that's going to be this one right here. Okay, that's the aligned memory pointer, that's the aligned pool pointer, and that's the original. So those are the three that we want to keep, or that we need anyway at this point. Okay, so now we're doing the malloc aligned pool pointer. Let's fix that in here. Pool size. Before I forget. Did I misspell something? Yes, I did. Okay. Yes, this is not spelled right. If aligned pool pointer equals null pointer. Okay, that should do it. Let's get rid of these things. I don't need all this extra space in here. Okay, we've already determined that we don't need this anymore, so let's get rid of that. And put this here. Okay. So, what we're getting back from the aligned malloc is the address of the aligned pool pointer, or the aligned class pointer. I should almost say. I'm not going to change it now. Then we're going to say the new pool, which is the memory pool class, equals new aligned pool pointer memory class name. So there you go. Okay, let's see. All right. Now let's talk about that aligned memory pointer. Let's set that. We're going to need that, right? So, aligned memory pointer. How are we going to set this? Well, remember what this is. Aligned memory pointer is simply this address plus the size of the memory. It's going to sit right here, okay? Yeah, I'll explain a little more about that in a minute. Okay, so what we need is the aligned pool pointer. Aligned pool pointer. Whoa, what are you doing? Plus size of memory pool class, like such. Okay, I'm going to get an error, that's fine. So basically, we've just gone back the other way. So what about alignment? Let's talk about alignment here. Well, remember, let me just back up here to this. We originally calculated this value. We know this is aligned to the requirements that we need, okay? Now, it turns out that size of a class will always be aligned to the requirements of that class. It'll be done by the compiler itself. Okay, so when we did this minus size of memory pool class, no matter what was in here, or what was in the memory pool class, right now we've got, assuming a 32-bit operating system, we've got 4, 8, we have 9 bytes in here. That'll actually round up to 12 bytes because this class should have a 4-byte boundary requirement. Should. If it was 64-bit operating system, that'd be slightly different. I think that's 16, 16 in one. And then it would round up to, 8, 8 in one. And then that would round up to the nearest 8-byte boundary. Okay. So this is aligned. So we know memory pool, so we know that when we go back here, this is aligned because the size of gives us an aligned, and this was aligned to begin with on a more stringent actually boundary than this one is actually. So then when you add it back in, you just get back to the same place that we started with right there. So there you go. Everything is aligned the way we want it to be. We have at least as many bytes as we're supposed to have, if not a few more. So we have everything we need. So we don't have to do any more fancy math, is what I'm trying to get at here. The only thing we need to do is fix this error right here, and let me put this down for a minute. I don't think I need that now. Okay. So the reason we're getting this error is because this is a size of, which is a unsigned int. This is a void star, right? So we want, again, this is the same situation we had before. We want the compiler to treat this address like an unsigned int. So I'm going to cast it to an unsigned int. like such. Okay, now we'll get the same error here. So I'm going to again do the same thing, reinterpret cast back to a pointer to a void. And then like such. Okay, and that should do it. Okay, guys, that should take care of that. We should be good. I hope. Let's see what happens if we compile. We still have some errors in here because I don't have these functions in yet. Okay, 6 errors. Same. It's got 3 errors that are reporting twice. Okay. Let's deal with some of this. So in the memory pool class, we want some public functions. Get pool ID, get original memory start, and we'll deal with the return values in a second. And get next pool ID. I just want to set these up real fast. Nothing super fancy here. This should be probably an unsigned int, I think. I may change that later. This will be pointer to a void, and this will be a memory pool class pointer. Okay. Let's just grab those and drop them into memory pool class, like such, and drop that code in there. Take off the semicolons. A lot of mechanical stuff to do when you set up a number of functions. Make sure they're in the class, and there you go. Uh-oh. Dropped in a... Okay. So now the compiler should be less unhappy. We still have 3 errors. Why do we have 3 errors? Oh, because we're not returning anything. Okay. Right. For right now, because I don't want to write these functions quite yet. I want to get this to a point where it's compilable because I want to test. So this one we can actually write. Original memory pointer. That's the one. And then get next pool. For now, I'll just say return null pointer. Okay, that should compile. Yeah, it's fine. Okay. Let's talk about the constructor for memory pool class for a second here. In the memory manager class, when we added the pool, we picked up all this stuff that we needed, right? These 3 pointers. One of them we used to actually do the placement new. However, the other 2 we didn't use, and we need to use both of them, right? So let's see here. Whoa. What I'm going to do is, because we can use any constructor we want to use for a placement new, I'm going to throw those in there. And the aligned pool pointer as well. At this point, we no longer really need the aligned memory pointer. Wait. No, this is not what I want here. I want the pool pointer. Not aligned memory pointer. Oh no, I was right. Never mind. Sorry, my bad. We did this. Okay, yeah. Okay, let me go back. So at this point, we no longer need the aligned pool pointer. We've used that already for the placement new. But we need the aligned memory pointer and the aligned pool pointer. Sorry, no, the original pool pointer is what we want, not the aligned pool pointer. That's what we want. The aligned memory pointer and the original pool pointer. These guys right here. This aligned pool and the original. We need to keep this. This one we don't really need to keep anymore. Once we do the placement new, it's set. We're done with that. Okay. So that should... hopefully I've got that right. All right. So let's go ahead and... That should be giving me an error. Yeah, it doesn't like that. So right. Let me grab memory pool class. So in the constructor, I want to put some new stuff. So we'll say the original and the aligned. And I think I did that backwards. Original and aligned. Yeah, I sure did. Let's put this over here. Okay. Very good. So then let's grab this. And we will drop that into here, like such. Okay, so the only thing we need to do at this point, really, is store those in the correct locations. So it's just going to be not the manager, the pool class. Original memory pointer. Equals original. And aligned memory pointer equals aligned. And then I'm going to put in a to-do, hash the name string and store it as the pool ID. We'll get into that later. So there you go. Okay guys, so that should hopefully work. Let's compile and make sure there's no problems. All right, what I want to do here is I want to convince myself that we do in fact have the offset right. This is where you really should test. So let me put a break right here. I'm going to put a break in. We don't want to actually malloc anything because we don't have the free working yet. And if we malloc it, we're going to leak memory like crazy. So let's just check that out. Right now we're in debug mode and I'm in x86, which is a 32-bit platform. And it should allocate that memory. I should have already told it to allocate that. So let's go ahead and run that. Okay, and now offset is now equal to 27. Okay, so remember we added 15, so you take 15 off of that, you're down to 12. We have 12 bytes of data, which is the size of this. This is coming up as 12. Is that right? Let's take a look. This is 4, this is 4, 8, this is 1, that's 9. And so, yeah, the compiler is actually padding that out by 3 extra bytes to put it on a 4-byte boundary. So you can see firsthand that usually the compiler will align stuff for you. This is why you never have to worry about alignment, except for this particular instance where we have to worry about it. But yeah, so that seems like it's working fine. Let's actually take out that misalignment. I deliberately put that misalignment in there. Let's debug, stop debugging. Thank you. Okay, let's go ahead and run again. And this time the offset is 23, which subtracting off 15 gives you 8, and that's exactly right. So in this case, it's actually aligned 4 bytes for that, 4 bytes for that. It's 8 bytes. It didn't need to pad it at all, so yeah, that's fine. Let's go ahead and stop debugging there. Let's swap over to an 86-byte, or a 64-bit platform. x64. Let's compile that. Hopefully it's, oh boy, we got errors. Why did I get errors? The WinProc is complaining. Okay, probably because I didn't really set it up right. The WinProc long. Okay. Okay. We can fix that. Let's fix that real fast. Let's see. Let's change this to, in order for it to work in both 64-bit and 32-bit mode, I think I have to change that to an L result, if I remember right. Because that goes to a type def long pointer. If I go to a 64-bit, an 86-bit, it then changes it to still a long pointer. I wonder if that's going to work. Well, let's try it. So let's see, where's my WinBase? This needs to be L result. Right, and then I probably have it under, where's it going to be? The control window class as an external, yeah. L result. All right, let's see if that compiles. That compiles under x64 and then under x86. That compiles. Okay, that's more the proper way to do it. That way it can do it either way, either 64 or 32-bit. That's the way I should have done it in the first place. I don't know why I didn't. Okay, we don't need that anymore. We don't need that anymore. We don't need that anymore. Let's go ahead and run that. We should still have our break-in. Okay, so now we've got an offset of 31, which 31 minus 15 would be 16. So you can see that we still have these two void pointers, but it's using 8 bytes for each, which it should do in a 64-bit environment. Now let's misalign it and run it again. Oh, let's not continue. Let's debug, stop debugging, and let's run it again. It should, if I'm not mistaken, now it's got 39 minus 15 would be 24. Right? 24. Which is an 8-byte boundary. So it's aligning the class on an 8-byte boundary in 64-bit mode. Okay? So there you go. I mean, it's working the way it's supposed to. So the compiler is in fact padding the class as necessary to make sure that it's on a boundary that it wants to be on, which will put us, if you look back here, remember we aligned this one, so this is always going to be aligned for us. This will push it back so that everything within the class is aligned the way it's supposed to be, because the compiler will handle that for us. If there's misalignments within the data inside the class, the compiler does that for us, just like any other program does when you build a class. So you don't have to worry about the alignment inside there. So there you go, guys. Very good. I think we have fixed that class now, hopefully. Let's see here. Let me pull up. Is there anything else I want to do in this episode? Let's see, the memory manager class. Yeah, we have the first and last pools. You know, I probably don't, because the next thing in our list to do is going to be the hash. We're gonna have to deal with that hash in the next episode, because right now we can't really delete this memory because we can't find it. We can't find the pool. Unless we save it somehow, which we're not doing, we got to use the string to find it, and we're not hashing that string out yet. So the next episode, we're probably going to do the hash, and that's going to take a little bit of explaining. So I'll save that for the next one. Okay, guys, I hope this all made sense. Sorry for that logic error in the first place. I realized after I did the episode, actually a couple days later, that what we had done just wasn't going to work, but this should work, and I think we should be good. Again, it's not really tested, but not, at least not completely anyway. So it could change again, but hopefully we've got it right this time. I hope so. So yeah. All right, so we'll stop here and we will pick this back up in the next video. So I will see you guys in the next one. Thanks a lot.